All right, so now we need to talk about levels of measurement. So the way a set of data is measured is called its level of measurement. So there's 4 different levels: nominal, ordinal, interval, and ratio. Data that is measured using the nominal scale is qualitative. Okay, that's important to remember. Okay, this is the simplest level of measurement, and it applies to variables that can be described solely by names, labels, or categories. So an example of this would be colors, brands, names, and this also includes yes and no data, which is important to keep in mind. As we go into Chapter 2 and learn about calculations we can do with our data, it's important to note that nominal data cannot be used in calculations. The frequency of the occurrence is the only thing we can see. Okay, there were 5 people in the class with brown hair and 3 people in the class with black hair, right? We can only calculate the frequency. Ordinal scale. In an ordinal scale, it's similar to the nominal scale, but it can be ordered. Ordinal scale has an order, okay? When we describe data with a ranking or ordering scheme, it's ordinal. For example, rating scales of movies or restaurants. Also movie ratings, like G to PG, right? Ordinal scale can also not be used for calculations. It can only be used for frequency. So here we have a nice little summary. Before I talk about interval. Okay, interval scale is quantitative data, okay? It has a definite ordering, but the difference is it doesn't have a starting point. Okay, so we can't make ratios. It doesn't have a starting point. Examples of that are temperature and time. There's not like an absolute 0. There's not a set start of time, and temperature, even if we say it's 0 degrees Fahrenheit or Celsius, right, we can still have negative temperatures. So this is interval data. Ratio data can be compared. It has a 0 point, right? Test scores out of 100 points, so it's a great example. You could get a 0. I doubt you will, but you could, right? We can say that 98 is as much as 49. We can make a comparison. We can say 20 is 1/4 of 80. So this is going to be our ratio data. So here's a summary of the possible data types and levels of measurement. So remember, qualitative data is categorical. These are kind of synonyms. Quantitative data is numerical. And we can break it down. I can have discrete data that can only take on specific values. That's interval or ratio. And I have continuous data that can take on interval or ratio data. So for discrete, it could be like years. For ratio, it could be exam scores. For data that's continuous and interval, that would be temperature. And data that's continuous and ratio, that could be height. So these are some examples for us. Here's a summary of the different levels of measurement. Let's look at an example. So, tell me if this is nominal, ordinal, interval, or ratio. So, names on a uniform that identify players on a team. Well, the names, that's going to be nominal. But this next one's a little trickier. What about the numbers? The numbers on a uniform that identify players on a team. Well, those numbers are also going to be nominal, because those numbers take on no real value, right? They're on the back of that jersey with the players' last names. They're just used to identify. What about students' rankings of cafeteria food as excellent, good, fair, or poor? That has a specific order, so that's going to be ordinal. What about calendar years of historic events? That doesn't have a starting point. That's going to be interval. Temperatures on a Celsius scale. Again, temperature is always interval. And how about runners' times on a Boston Marathon, right? When you're timing a runner, you have your stopwatch and it starts at 0. So we have a starting point. We could make a comparison. This is ratio data. So now I want to talk about dealing with errors in our data. So there's two different types of errors. One is random, right? And this can occur because of random and inherently unpredictable events in the measurement process. And the other one's systematic, okay? That means there's a problem in the measurement system that affects all of our measurements the same way. So if I put a baby on a scale and he's wiggling around, right, that's a random error. But if my scale is always off by 1.2 pounds, this is going to be a systematic error. So absolute error describes how far a claimed or measured value lies from the true value. So absolute error is the claimed or measured value minus the true value. While as relative error compares the size of the absolute error to the true value, and this is often expressed as a percentage. So to find the relative error, we take absolute error divided by the true value times 100. So let's find the absolute and relative error. Your true weight is 150 pounds, but the scale says you weigh 155 pounds. So for absolute error, I take my data value minus the true value. So in this case, I take 155 pounds minus 150. So my absolute error is 5 pounds. Next, I need to calculate my relative error. Relative error is my data value minus my true value data value minus my true value over the true value times 100. So that's me 5 divided by 150 times 100 gives us 3.3. So it's a 3.3% error is our relative error. When we describe our results, we want two things to be true. We want to have accuracy as well as precision. So accuracy describes how close a measurement approximates a true value, okay? An accurate measurement is close to the true value. Precision describes the amount of detail in the measurement, right? It'd be more precise to measure in inches than it would be in feet. It'd be more precise to measure in millimeters than it would be in centimeters, because that's a more precise level of measurement. So let's suppose your true weight is 102.4 pounds. The scale at the doctor's office, which we read only to the nearest quarter pound, says you weigh 102.25 pounds. The scale at the gym, which gives you a digital readout to the nearest 0.1 pound, says that you weigh 100.7 pounds. Which scale is more precise and which is more accurate? Well, the one that's more precise is going to be the one that can read out to the nearest tenth of a pound as opposed to the quarter, right? That's smaller. So that's going to be the one at the gym. However, the one at the doctor's office is a lot closer to your real weight. So the one at the doctor's office is what's more accurate.